Well, hello everyone, and welcome back to Adrian's Digital Basement. On today's video, I'm going to try to revive this sound card. It's a Sound Blaster CT1350B, which I think is also known as the Sound Blaster 1.5. And this one, well, it's seen better days. I found this in a pile of scrap boards, and as you can see, well, one of the chips on here has been rudely ripped off, with witness marks showing someone must use a screwdriver or something like that, and some ripped traces. So because these Sound Blasters are now rather old and getting kind of rare, I'd like to get this one fully operational again. So without further ado, let's get right to it. The Creative Lab Sound Blaster 1.5 was essentially just a slightly cost-reduced version of the original Sound Blaster, and the original Sound Blaster being a sound card that had digital audio recording and playback capability, along with ad-lib compatibility and Creative Music System compatibility. The Creative Music System, or also known as the CMS, had two square wave generators. It's these two chips, and it offered stereo output of, I think, up to 22 square wave channels. And you can install two of those square wave generators onto this board, along with a PAL or GAL chip here. There's a replica available, and that makes this fully compatible with the original Sound Blaster, and it's really just three sound cards in one. Through this 15-pin connector, the card also brought to the table a built-in joystick port that just saved you having to buy an extra card, along with MIDI output that is possible if you have a special cable. This jack is the speaker output or line output, and this is a volume control for that connection. And we have a microphone and a line input with these two jacks. Obviously, besides the missing chip, we're also missing the slot bracket. And unfortunately, I looked around and I couldn't find an STL file to print for this slot bracket for this particular card. I was able to find the one for the Sound Blaster 16, but unfortunately that one is not compatible. I checked the position of the jacks, and if I printed that, it wouldn't actually work. So I'll just throw out there, if anyone is aware of an STL file for the Sound Blaster CT1350B, let me know, because I would love to get this printed. So, well, if I can get this thing working, I can then use it inside a computer. Now, the condition of this board appears to be quite good. I don't really see any kind of damage anywhere on it, except for the obvious thing that happened in the corner there. The rest of the board looks relatively unscathed. The genuine Yamaha YM3812 OPL2 synthesizer chip has a date code of 1993 50th week. The only other obvious date code I can see that I can actually decode is this one there, 1994 first week. Now, I think the first thing I'd like to do is try this out inside of a PC and just see what works on here and what doesn't. I don't actually know exactly what's not going to work missing this chip, but it's worth a try. I think before I do that, though, it's going to be worth going over this board and looking at it a bit more closely just to make sure we don't have any broken traces. Because if it's anything obvious like that, then I can fix that before we give it the initial test. But really, so far so good. Everything looks excellent on here, considering the condition of this. This is interesting down here, though. What's happening there? Is that just some gunk? Or is that like a burn mark? So I'll just put a little 99% IPA on there. Get a pick. Just see if that... Oh, that's absolutely nothing. Okay, cool. Anyhow, looking at the rest of this, absolutely perfect. I don't see anything wrong, at least on the back side. Looking at the top side, everything looks really quite good. In this lower corner with the ISA slot connector, currently set for IRQ5 and DMA channel 1. It doesn't even look like there's any other way to change the DMA channel other than, I guess, not selected entirely by removing that jumper. The capacitors are a bit scratched up, just indicating this thing was thrown into a bin. This is where I found it. So there would have been a bunch of boards just sort of pressed on top of it. There is a jumper here that says FM. Not exactly sure what that means. And this one here says voice. It's always possible when you find scrap boards that someone has stolen some jumpers off of it, which could potentially disable some functions of the card. We also have some jumpers over here, but I'm pretty sure this has to do with the line in and microphone in and maybe hooking up to internal connections inside a case. Certain OEM configurations had a little amplification circuit built in and maybe some extra jacks on the front, and you would potentially connect up to these connections there. As I mentioned before, these are for the square wave generators. I think it's a Philips SA something or other. And it looks like we have CMS off jumper. So you set that jumper if you want to disable this, if these are not installed. And then there's also a jumper to enable and disable the joystick port. Looks like potentially it's disabled right now because that jumper, I assume, would be on if it was enabled. And remember I said this was from 1994. It looks like the silkscreen has a 1991 date code, and I don't know if that's for the 1350 or one of the other versions, and I don't even know all the different slight variations of the early versions of the Sound Blasters. But I know the B one was absolutely the last one to be sold that has the full compatibility with the old CMS system by installing these chips. We have one more jumper over here for DMA control, and DMA is used for the digital audio on here. And then we have the base I/O of the main Sound Blaster card itself, either 220 or 240. 220 is almost always the most standard configuration for Sound Blasters. Now this is the Creative CT1350B IC, and this one I don't think is something you could replace. But the one that's been ripped off the board, luckily, is a chip that is replaceable. And for the best of my understanding, the missing chip on here is a standard microcontroller, an 8051 Intel, or one of the variants. I don't know if the original ones from Creative Labs were mask ROMs or they were one-time programmable chips, but luckily the chips are still available, and since the community has reverse engineered all the code that was on them, well, now I should be able to revive this sound card. I had previously showed this card off on a channel a while back, and I was despondent that the card was pretty much useless, and I just grabbed it thinking that as a minimum I could get this OPL chip off of here for use on like an AdLib clone or something like that. But then people told me that it would be possible to get a new version of this chip and bring this card back to life. So I've been talking with Alex over at the Bits and Bolts channel. Alex made a whole bunch of RAM upgrades for various sound cards, which he's gone ahead and sent me, and actually have a second channel video coming up where I test those. But in the package that Alex sent me, those RAM upgrades, he also sent me a replacement 8051 microcontroller for this Sound Blaster so I can get this working. In fact, Alex went ahead and he sent me two. This is the one that's going to go on this Sound Blaster, so it's version 2.02. But he also sent me 4.13, which isn't for this card specifically. This is for later Sound Blaster 16s, which I guess Creative Labs was still using the same microcontrollers with updated code on them, I think known as the DSP code. And apparently this one fixes the hanging note bug that is so common to the Sound Blaster 16s. And it's because apparently this chip is handling all the digital output, maybe the input as well, but also is handling the MIDI stuff that's through the joystick port. And that's where that hanging note bug comes from on the later versions of the Sound Blasters. Now there's the Atmel AT82C52 chip that Alex has gone ahead and programmed for me with the 2.02 code for installation onto this board. And hopefully after we do a little bit of repair and work on this thing to clean up the damage, this thing can work again. If you haven't seen Alex's channel Bits and Bolts before, I highly recommend you take a look at it. I've been watching his channel for a long time because I love watching repair videos. And Alex has done a lot of revivals of old motherboards, sound cards, and video cards. And I just love seeing that stuff. And Alex's designs of things like the MIDI Forge, which is a wavetable synthesis card, is all open source, so he releases that all back to the community, which I absolutely especially love. And it goes without saying, Alex sent me one of these chips here to save me the work of having to buy the programmer and finding the right versions and things like that, because he said that this is what I need specifically to get this card working. So I think the first thing I want to do is I want to see what the state of this card is as it is right now with this missing chip. And to do that, I'm going to be using my 36SX test bench here. I have this all set up and ready to go, so we're just going to pop this in. And let's power this up, 3, 2, 1. There's no weird audio through the speakers. I have my test bench configured for Blaster A220 i5 D1, that's DMA channel 1 and T2, which I think is the appropriate type for these types of Sound Blaster cards. It's nice that the machine itself is booting, so the ISA bus is not corrupted by having the sound card inserted into it. And from the best of my understanding, as I mentioned a little while ago, I think the little chip that's been removed here is responsible for the MIDI operation and the digital audio side of this card. But I think the AdLib functionality, the OPL2 stuff, probably should totally work. I also am not really sure that this card has any mixer functionality like the later Sound Blasters do, where you have to use a program like Mixer Set to control the level of the FM audio or the digital audio or, the CD audio that's going into it. This doesn't really have any of that. I think it all just is mixed together in the little audio section of the card. Right, so I'm going to run the AdLib Jukebox program because this should totally work perfectly if the OPL2 functionality of this card is working perfectly. So let's just give this a test. Oh yeah, that works. Now, one thing I can tell right now is the audio coming out of this card is really, really noisy. I think that's kind of normal. It could just be that there's like a dirty connection here on the audio output, but I also think that's one of the problems with the sound card. I think there wasn't a lot of good isolation when it came to the bus noise getting through to the speaker output, so I can really hear that through the speakers here. Right, so the ad-lib functionality of this card is working fine. That means I bet you any game that uses ad-lib, like say Planet X3 from David Murray, yeah, we have working music here as well. No problems. And yep, there we go. Cool. I'm not surprised because things like this don't rely on the Sound Blaster functionality whatsoever. Right, so when it comes to testing the digital audio portion of this card, I don't know if I can use the Sound Blaster 16 diagnose utility. Let's see if it can recognize anything. Okay, no. Well, I mean, I don't know, actually. This isn't really a good test since this card's functionality is kind of broken. So it's not finding it, but I'm not sure this utility ever finds it. As I said, I do have the blaster variable set appropriately, so theoretically I should be able to run any utility or game that uses the Sound Blaster card and it should work. So for instance, let's try running Cubic Player, which is a mod player for MS-DOS, and I hit pause, that's loading, and it says Sound Blaster not found, optimize your cp.ini. Well, I happen to know that the INI file is already set for Sound Blaster appropriately, and it will auto-detect the Sound Blaster based on the blaster variable, but it's not finding the Sound Blaster. And the next program we can try using is Freddy's ModMaster XT. This is a mod player specifically designed for playing mods on a really slow computer like this is 36SX, but it's also designed to actually work on XTs themselves. So this Sound Blaster, if it was working in an XT, theoretically could play mod files with Freddy's tool here. It says here that it only found the OPL2 at port 388, so it did not find the Sound Blaster card. And that means if we try to play any kind of mods here, well, it's clearly not going to work. And yeah, it's just playing through the PC speaker, which doesn't sound good. All right, well, we have some signs of life out of this, which is great. So OPL2 side of the card is working, so that implies that our bus transceivers here are working properly. Not to mention there's probably some select logic on here that selects this, that allows that ad-lib compatibility that this card brings to the table. We can tell the amplification side of the board is working. It's a little noisy, but I really do think that that's just totally normal for this card. I suppose it's possible some of these caps might be kind of unhappy, but I doubt it. I've never really had any trouble with this. This whole shielded area here has to do with the audio amplification section. They're trying to keep it as noise-free as possible, but it's not so great on this card. Now, taking a look at the corner, the X was drawn by me, so that wasn't there originally. We have at least one missing pad. Some potential damage right there with that trace. We'll have to look into that. Looks like, is that a missing trace that's been ripped there? I don't think so, actually. That pad probably doesn't go to anything. I mean, amazingly, considering this thing was obviously just like ripped off with a screwdriver, like someone had just like stuck a screwdriver in that corner and just pulled up. I'm shocked in a way that the only damage is this right here. And I guess we're gonna have to figure out if that even goes to anything. That might actually be a pad like one of these that doesn't even go to anything at all. And it's kind of curious that there's a little bit of modeling in the PCB itself in this area. Is that from stress maybe? And I don't know what this black stuff is that's on the board. So probably the first thing I should do is I'm gonna grab a little of this Chemwick here and I'm gonna try to clean up all of those pads. Just get everything flat and smooth again because this is all sort of bumpy from the leftover solder that's on the board when the chip was just unceremoniously ripped off. Now, a trick about using this stuff is just cut a small piece off with some flush cutter or something like that. That way, when you're using this, it doesn't try to wick all the heat away into the rest of the wick. This is obviously made out of copper, so it's very conductive of heat. And it needs to be up to temperature to properly melt the solder so it gets absorbed into this. In addition, I'd recommend avoiding the cheap versions of this stuff. I found that it's hard to use, doesn't work that well. MG Chemicals Super Wick and the Chemtronics Chemwick are the two that I like. So I always keep these large rolls of this stuff handy on the bench. And this is rosin filled, which helps it wick up the solder. So if you have some cheap stuff that doesn't work well, try adding a little bit of rosin flux onto the pads, which may help the situation. I'm going to start with a little IPA on here, and this should remove any of this black ink that I put on there when I was drawing that X. And can we get off whatever that is? No, not really. I don't quite get what this is. And it isn't on the backside at all. Yeah, it's kind of weird. I guess it's coming off a little bit. I'm going to try to spend a bit of effort or time here and just clean this up a bit. And while I was scrubbing, I noticed that that one is not in great shape. That pad is now detached from the board. So far, everything else seems okay, but the stress of it just lifted it. For the cleaning process, I'm going to start with the soldering iron set to about 330 degrees. And, well, we're just going to try to clean this up a little bit. And, yep, that solder just melts without any issue. This is probably manufactured with leaded solder originally. And it's no problem that this stuff is kind of getting stuck together because I'm just going to melt this. And then I'm going to use that braid, that little piece I cut, to suck all this up. Oh, damn it. I broke another one of the pads right there with that cleaning process. I didn't even notice that when I was talking about the other one that was messed up. So let's start cleaning up these pads a little bit here. So what I'm trying to do here is I'm just trying to get off any of the excess solder. There's going to be a tiny bit on these pads because they'll be tinned, but I don't want them to be raised because originally they were raised up. And when we're going to try to reattach that chip, we want it to be flush so that I can get this thing reattached. I can resolder it back on there. So I'm just making sure to not go side to side since the pads are already kind of fragile as it is, as I just disconnected an extra one over there. We'll get to that in a second. But we're going to go through and just try to carefully clean this all up. And when you use this braid, it gets really hot, which is why I'm using these tweezers to hold it so I don't burn my fingers. And you have to be careful when you're using this stuff. Sometimes the braid can adhere to the pad and you don't want it to be attached and then you lift up and rip the pad off as well. Let's see what I can do if I can try to fix this mess I made here by cleaning it. You know, this was in perfect shape. And then I rubbed it really hard to get this black stuff off, whatever this gunk is. And I caused this thing to become dislodged. Right, so I flipped this over. I think it's still twisted, but I don't want to manipulate it too much because if you do, it's just going to break that off. And at least right now, there is a pad there. So if I can get it attached to the chip will be held on physically with the rest of these since these are all still attached. This one, on the other hand, if I have to run a bodge wire from that via to the leg of the IC or the little part of the IC, I can, no problem. But I'd rather at least the pad be there because it's actually a good chance that we might be able to attach it and not even need a bodge wire. So let's try to clean up the rest of these pads and maybe be as careful as I possibly can be doing it. I'm missing or skipping the pad. That's messed up there. Okay, so I think this is gonna work. I guess what I just don't know is if that is a via that connected to a trace and that. Not to mention, there's a little black mark right there. I think that's just, oh, that came off with the iron. Okay, so that pad was never connected to anything. All of these look fine, as far as I'm aware. I'll check some continuity, especially over on this edge, in a moment. Because see how this trace is kind of mangled there? So that pad obviously has been kind of screwed up, so it needs to be connected to that via. That pad's a little mangled as well, but I think it should be good enough to connect to there. So it's really just figuring out if this was actually ever connected to the microcontroller in the first place. Now when it comes to this card and this missing trace, luckily I found a thread on Vogons, which will give us exactly the information we need to be able to figure out if there is a missing trace on here and what it actually went to. And it's this 2022 thread posted by ThermalWrong. Basically, ThermalWrong ended up with CT1350B just like this, but a gold scrapper had freaking just sliced off the ISA edge connector, which is kind of amazing to me. How much effort was that to get like the tiniest amount of gold that's actually on this edge connector? It's not even that many pins on there. But I suppose if you do 1,000 of these cards, eventually you'll end up with a tiny bit of gold, and I guess it's worth your time. And what this user decided to do, well, is try to recreate this PCB from scratch. How freaking cool is that? So all the ICs and other components were removed, including the slot connector. High-res photographs were taken, and then a whole bunch of tracing and reverse engineering was done on the board. And it looks like if we go down far enough in the thread, the replacement PCB was created. And I don't know if the Gerbers were released for this, but it looks like down here, this very last post, someone was talking about finding the CT1336 chip. That's the Creative Labs chip that's still on this board. available on UT Source. Now this was back in 2022, and further down here it talks about the Atmel microcontroller. That's the one that Alex from Bits and Bolts sent us. So taking a closer look at the work that Thermal Wrong had done, there's the board again with all the chips and parts removed. And here is the upper corner we're interested in. So what's unbelievable is the missing pad that's missing altogether is this one, which clearly doesn't connect to anything. And in case you're wondering, this is a photograph of the top side of the board, and then the bottom side of the board was also a photograph, and then the colors were changed so it could be overlaid on top of each other. So the red traces are the traces that are on the back side of the board. Very typical way to do reverse engineering work. And then finally, here are the schematics that Thermal Wrong did. Let's zoom in a little bit, and let's see what exactly this chip is connected to. So there it is, the AT89S51. Which, incidentally, when we take a look at the datasheet for that, it is an Intel MCS51 compatible chip, so that's like an 8051, and it has 4K of in-system programmable flash memory, 5-volt operation, up to 33 megahertz, well, at least this particular version of the chip, and a bunch of I/O lines and other capability, 128 bytes of RAM as well. So here it is, we have some address data lines, so multiplex address data lines that are connected to the other chip. That's the CT1336, and then we have 8 bits of DAC outputs that make their way from the microcontroller down to the MC1408 little DAC chip on the Sound Blaster. So that's obviously for the DAC output. And this does use a little 12 megahertz crystal, which is installed on this board. Luckily, that's not removed, but luckily 12 megahertz should be pretty easy to find. Looks like we have DSP read and write signals. It probably comes from something else on the board somewhere. Interrupt signals, MIDI in and out. That's the transmit and receive. Reset line, voltage. That's all pretty standard stuff. So it's kind of what I was saying, that with this chip missing, without a doubt, we're going to have non-functional digital audio output because it comes directly from this chip. Not to mention the MIDI functionality will be totally not working either. And it looks like when it comes to the functionality of the OPL2 or the ad-lib synthesizer working, the reason why it works is because the chip select line for the OPL2 is connected through this jumper CMS off, because we have that installed on the board. Because normally the GAL for the Creative Music System is what actually drives these chip select for the OPL2. But since the GAL's not installed, the jumper's installed, it's actually connecting the chip select line to the CT1336 signal, which looks like it goes normally into the GAL itself, but it's actually going directly to the OPL chip, and that makes its way up to CT1336. And it looks like the ISA bus connections, like the I/O read and write, that's the I/O port stuff, IRQs, things like that, all make their way into that CT1336. So without this chip, I think pretty much nothing would work on this board at all. So I'm really glad that it was this quote-unquote DSP chip that went missing, because this doesn't seem to generate any chip select lines that go to anything else. It has these DSP read and write signals that are coming from probably this CT1336. Let's see, where are those signals? There it is, DSP read and write. I have a feeling even though these signals are on the left side of this chip, I think they're actually outputs from this chip and they're inputs on this chip. The normal convention would be the inputs would be on the left side and the outputs would be on the right side. But the way this person did this schematic, which I'm not complaining about because the fact that this schematic exists is awesome, because I'm pretty sure it's the chip select lines coming out of this chip that go and drive this chip. But either way, that's neither here nor there. I just wanted to see why the ad-lib stuff is working, and it's working because chip select lines are coming from the chip that is still on the board. And to the best of my understanding, I'm pretty sure that software is able to communicate over the ISA bus to the DSP microcontroller and query the version number, for instance, because I've seen plenty of things query the version number on Sound Blaster 16s. I can't remember what version you typically see, but it looks like the data lines and the address lines come through into the CT1336, and then we have these multiplex address data bus lines that go between these two chips, and that allows communication to the DSP chip, which is missing. So I think what this all tells us is that the damage that was on the board here is theoretically inconsequential, and I should be able to take this DSP chip that Alex sent me and just install this on the board. It should go in that configuration like so, with the notch on the silk screen matching the notch on the chip, and this thing might just work again. To accomplish this, and I'm pretty terrible at surface mount soldering, so don't follow what I'm saying here. This is just what I'm going to try to do to make this work, is I'm just going to add some rosin flux onto these pads. I'm going to be careful around here because I know we have a couple pads that are loose and floating around. And in fact, this one here needs to be moved over a little, just into the right position. We'll drop that on there. Oh boy. I'm a bit out of my depth here, I think. I'll just position this into the right position, about as good as I can get it. And I'm gonna try to get this thing soldered onto the board to revive this old sound card. Now, one way you could try to reattach this is using hot air. But, of course, I would need to tin all of those pads first so they're coated in solder, and they are not right now. Theoretically, you could use solder paste and then pop this chip down like that and then use hot air. And with the right amount of hot air and the board heating up, it should center and just attach itself. I'm wary of hot air when we have a bunch of pads that are loose and about to fall off. So I'm going to try to manually solder this onto the board. And the way I'm going to try to do this is I'm just going to hold this down onto the board. Oh, that didn't work properly. And the way I'm going to try to do this is just get this centered again, because I touched it and it moved. And I want to attach one corner here and one over here, like maybe that one, because I think that one's not ripped off. Make sure it's all aligned correctly, and then just go around the whole thing and try to get it all attached on all the other pins. I'm just going to carefully push it down, try not to let it slide around. And I have some solder on the tip. Maybe that's attached. I don't know. I just rotated the board. Here we go again. I'm going to push down without sliding the chip. I'm going to get that. That was way too much. Try to clean that up a little bit. Okay, I think we have at least one good joint. I'm just trying to get the tip on the pad and on the leg of the IC at the same time. So I'm going to push down onto the board and get it on the leg of the IC. Oh, okay, well, it's no longer attached, and I think it was. So let's try that again. There we go. All right, I'm going to do another corner. I am terrible at this stuff, so please forgive me. There are people that are way, way better than this than myself. But the way it works is you just have to try to be methodical about it. And the flux really helps kind of get the solder all over the chip, all over the board. All right, so looking at the chip sideways on, looks like it's lined up well there. I think this side is good. Yeah, we're missing that pad, but that we know that doesn't matter. This side here, it's looking okay. I think from an alignment perspective, that's all I really care about. And that side looks good too. I mean, it's ugly, and I've only attached a few pins. Now I'm just going to try to go and do the rest. I'm going to leave that side for last. I want everything else to be reconnected first before I get to that side at all. And because it's attached with several pins now, I don't have to be quite so careful, at least when it comes to making sure it doesn't slide around. Okay, so first side is connected, and I'll have to go through afterwards and just double check that all of the connections from the top of the chip are connected to the pad. It's a bit ugly and hard to see because of all the flux that I have on there, but I think that's all connected. All right, the next side I think is done. So 2 down, 2 more to go. All right, third side is done. Looks okay. I haven't tested continuity or for shorts on any of this. Now we have the third side. Cross your fingers, everyone. Incidentally, I'm using this iFixit Smart Hub soldering iron, and it has kind of a chisel tip on there, which actually is really useful for this because you can kind of get it down onto the pad and onto the side of the chip itself. Okay, so this is one of the messed up pads. Just making sure not to drag it side to side too much. I think that one's done. One of these was messed up as well. I think it was this one, which looks like I already have that done. I think this one needs to be done. this is probably the last one here. Here we go. Okay, how does that look? I think this one is probably not attached properly. Obviously that's not attached because there's a missing pad there. But I think the rest are good. So let me fix this one there. I think that looks good. I mean, it's a lot of the crusty rosin flux on there. Oh, look at this, a little extra thing on there. I should get that off. Oh no, that's stuck on there really well. Okay, that's fine then. First step, we're gonna be checking for shorts. So I have this set for continuity mode and the beeper enabled. And the whole point is to go through all of the pins and check all the adjacent ones for shorts. Now we might need to check the schematics because there could be a couple pads on here that are connected together like ground or plus 5 volts. So let me quickly go through this just to make sure that any of my soldering didn't result in shorts, at least between 2 adjacent pins. All right, no shorts. Next thing I have to do is really just check to see if there's a good connection, for instance, like from a via like that over to the top of the pin on the chip. So that looks good. And I'm just gonna go through this and just double check that that similar thing is happening on all of them. Now this pin, I might have a pad that's not connected to anything, or I can't remember, you know, the pads underneath or the traces underneath. So with these, what you can do is just touch the top of the chip and then slide over on the board to try to touch the pad that's there and make sure there's continuity. But if you have a nearby via, it's obviously the better way to go to ensure you have connectivity. Also, we know some of these were a little bit mangled up, so that helps just ensure that those are actually connected properly. All right, so as far as I can tell, everything is connected on here. And I just had a scary thought that I put this on the wrong way, but you know, the notch of the chip and the notch on the silk screen definitely lines up. This dimple on the chip is pin 1, and it coincides with this dot on the silk screen marking, so that tells us we have this on the correct orientation as well. Now I just have to hope Alex programmed this perfectly. I'm sure he did. It's definitely the one, 2.02 is the one I used, which is absolutely the right one for this board. So let's hope this board comes to life, because taking this thing off, it won't be fun exactly. Before I clean it up though, I'm gonna give it a test. That flux on there won't cause any harm. I have the audio hooked up, so if we hear a whole bunch of horrible noise or some smoke comes off the board or the chip gets really hot, then this was a failure. So here we go, 3, 2, 1. Okay, no bad noise. The chip is not even warm. That's a good sign. Right, first we're gonna start with jukebox highways. Uh-oh. We don't have any sound. That's not good. Oh, maybe the volume is turned down? Oh, okay. Whew. I was worried there. I was worried that I made it worse. Let's try Mod Master. Oh, Sound Blaster detected. DSP 2.02. That is good. That is very good. All right, here we go. Let's try Eternity by format. Oh, it's playing out of the PC speaker. I think I have to select Sound Blaster. So it's going to use 22 kilohertz mixing, which I think is the fastest this can support. It says Sound Blaster 22 kilohertz mono 50% for the volume level. Let's hit play on format, Eternity. Okay, it's working. It's a little scratchy sounding. I think that's the way this mod player sounds. Well, that is a huge success. Right there, we know the digital audio output is working perfectly on here. So this new DSP chip did the trick, and well, like I said, those rip traces or the rip pads didn't cause us any actual problems. Let's try Cubic Player. I just want to see if this can detect the Sound Blaster now. Get ready to hit pause. It does say Sound Blaster not found. You know what? This might not support the original Sound Blaster and might only support Sound Blaster 16s. I think that might be the case. How about Diagnose? That's what we tried to do earlier. Nope, that doesn't work either, but I guess that's just par for the course. let's try Fast Doom. This is a 360SX40. It's gonna be terrible performance, but at least it should work. So we'll do Sound Blaster for both the FX and the music card. We will do 4 channels of mixing at 11 kilohertz, and I will just say keyboard only since I don't have a mouse even hooked up to this. Let's see if we have working sound and music. So we'll do regular Doom, and I think if I like make the quality super low, this should at least work. Boy, there's a lot of noise on the ISA bus coming through right now. Sounds kind of cool. It's so noisy. This can't be right, the noisiness of it. Okay, so we're in potato quality. It's bad, but the performance isn't terrible. Let's start the game here. I wonder if this is just due to my capture setup that the noise is being picked up. Look at that, 30 frames per second. And we're not rendering the floor or the ceiling. And the quality is horrible. But it's working. This is just like so bad looking. You can barely make these guys out. Whoops. Well, it's configured for keyboard. That's the problem. I was just struggling a little bit. It's configured to use mouse and keyboard right now, and I just have it configured for mouse. See, like I can strafe, but I have to use the arrow keys to turn, and it just doesn't really feel natural the way it works. But the music and the sound is working now. So outside, we have 8 or 9 frames per second at high detail. Low detail, it's like 12 or 13, and then potato is, wow, 16. So if I were using this computer, I think I would just use low detail. And this is with Fast Doom, which didn't exist back in the day. This is playable, I would say. This is plenty playable on this old 386SX. And when you go inside, frames per second jump up a little bit. Look, we're up at 20 there. I'm looking at the wall at least. Yeah, it's playable. I mean, if all your friends had Doom and you had a slow computer, and Fast Doom existed back in the day, I think this would be pretty acceptable. Just a little infighting to get rid of these guys since I have no better weapon and I can barely operate this with the keyboard here. Okay, so it's kind of funny is I have the volume turned all the way down and all the noise is still coming through. So I almost feel like this is like a ground loop problem of some kind. So I unplug the cable, there's no noise. Now part of the problem I think is that this entire system is connected to my bench PC through the VGA cable here. So we might be getting like a ground loop, but actually plugging this back in is still very noisy. But I have a feeling if we just hooked up through amplified speakers, which I happen to have, I think it won't be so noisy. How about a couple CS150 lab techs? Who remembers these? You don't even have to have batteries in here to operate them with amplification turned on, because if you have the amplification switch set to off, right amp off, left amp off, then just plugging these speakers into the sound card, the amplification on the card should do the trick. So it's plugged in there. Now we can hear the music through these speakers. And it's definitely less noisy. I still hear noise, but it's less noisy. So I kind of feel like the noise we were hearing was some kind of a ground loop or something to do with my capture setup going into the DAC over there, or the ADC I mean, that was causing that kind of extra noise that this card on its own plugged into some speakers like you would have used it back in the 90s would be fine, totally fine. Okay, so now I'm just doing a little bit of cleaning just to get this flux off here, and I'm just trying to be very gentle, especially on the side that's kind of messed up. I don't want to dislodge any of those traces that are just barely holding on. I'll just focus more on the other side. I'll just let the flux run off the board onto the paper towel I have on the desk here. Well, that looks about 1,000,000 times better. There's still evidence that this board was brutalized, but at least now it's fully operational thanks to Alex and a little bit of rework. So I'm just going to stick his sticker up in the corner here. That was thanks to him sending in that new microcontroller that this Sound Blaster is now fully operational. right? So this Creative Lab Sound Blaster CT1350B is now fully operational. I just need to 3D print a bracket for it. If someone could find one of those and send it to me, I would greatly appreciate it. And I think I have some extra SA1099 chips, I think it's called, around. I definitely have a gal chip I can program so I can get the CMS compatibility working on this board as well. So a huge thanks goes out to the community, ThermoWrong over on Vogons, for posting the schematics that he reverse engineered off one of these boards so I could validate that I didn't even need to worry about recreating those missing traces or pads that were on here. And a huge thanks to Alex over at Bits and Bolts for sending me over one of these DSP chips to install onto this board and pre-programming it for me, because this was much easier to repair than I thought it was going to be. I just assume when you pry a chip off, like was done to this poor board, or however this chip got detached, that more damage would have come to it. But in the end, we had a couple, or one missing trace, a couple bad pads that had kind of come free. But this thing all went back together quite easily without even a bodge wire. So if you enjoyed this repair of this old Sound Blaster 1.5, I'd appreciate a thumbs up. But if you didn't, you know exactly what to do. Huge thanks to my supporters. Making their names will go on the side of the screen. My voice is a little bit raspy if you've noticed, and that's simply because I was at VCF Midwest last weekend. So hi to everyone I met at the show, and reminder, if you took a selfie with me and you haven't already sent it to my email address, please do so. If you look at the YouTube channel About page, or you go to my channel and you click on About or whatever, there's a way to send me emails through there. It has an email address, and get me that photo. I really definitely appreciate it. And I guess that's gonna be that. So subscribe, all the usual YouTube stuff, and stay healthy, stay safe, and I'll see you next time. Bye.